show you how we made design for buoy position tracking system.
This system consists three parts. The first is the transmitter. The transmitter is placed on buoy. The second is the receiver. The receiver is placed on the ship to monitor the buoy. And the third is user interface.
Buoy is a type of an object, as locator or as warning points for the ship used in the middle of the sea. To check the temperature, humidity, pressure, and altitude, we use BME 280 module. Data transmission via wireless media radio frequency using NRF24 L01. Heading information from compass module, GPS to detect location. At the end, data using MQTT protocol would be displayed on dashboard on the right.
In this section, the transmitter sends two types of data, location data and weather data around the buoy. There are two main components, Arduino as a microcontroller and NRF24L01 as wireless communication. Let's start design. Before starting, we must design a block diagram, and then we need components in designing the transmitter system. The first component is Arduino Uno. As I previously explained, Arduino Uno is one of the main components that will be integrated with the Arduino IDE software. Second, NRF24L01 is the main component for wireless communication for sending data. Third, uBlock's Neo 6M GPS module to find out the location of the buoy. The last component, BME 280, is for reading the weather around the buoy, such as temperature, humidity, depth, and pressure. This is the wiring to do the transmitter system design. Let's start the code. This is the code for designing the transmitter system design. First, here, declare each component library. For wireless communication, we give name radio for pin 8 and 7, CE and CSN. For temperature, humidity, pressure, altitude or depth, latitude and longitude data in one data packet with struct data types. Now, let's set up. We start wireless communication NRF24 or radio, because it is function to send data, then set up radio writing, which contain especially addressed to the destination of the receiver. Radio setup by maximizing the distance traveled and the speed in sending data. Because we were sending data, so stop listening. Then set up the BME 280 library with data reading by I2C communication. In void loop, set the GPS reading data with data latitude and data.longitude is the given to each data type according to the GPS module library. And then set BME 280 when reading data.hum data.temperature, data.pressure, data.depth or data.altitude on the respective data type according of the BME library. After the GPS and BME modules read the data, it will be sent in the form the data packet, which was previously declared with the data struct type. After uploading, we can see the whole data that has been sent to the receiver.
And then, the receiver is also given the GPS. Data from the transmitter will be processed again at the receiver. The result will be displayed on monitor, LCD, and UI.
As we can see, here is diagram block of receiver system. To build this, you will need two Arduino Uno, a GPS module, a compass module, a wireless module, and RF24L01, a LCD, and you will need software for source code, which is Arduino IDE. Take a look at this schematic, which show how to GPS and compass module communicates via connection. So we are using the Arduino software serial library and wireless module and RF24 with SPI communication. Okay, let's getting started with Arduino source code. First, we have to make the code for master. As we can see here at the top, we have some include library. So we include tiny GPS++ for GPS module, software serial wire, Mecha QMC 5883 for compass module. So after that, we're going to go ahead and define pin we connect it to Arduino board and declare the function. In here, we have the setup to basically output and prepare for the serial module and sensor. We start serial connection and software serial for GPS, wire begin, and QMC init for compass module. And this is the main part of the program right here from void loop. Everything all the program is basically in the library. We check any data on the software serial and then read using the GPS library and compass module library. Then we calculate the heading error for compass module. Alright, we send the data using string send data. String latitude plus string longitude plus string heading error. We are gonna send data with Arduino serial communication. We put 1 second delay, so we wait 1 second before accessing the sensors again. Next, let's move on to the receiver's program. Include the SPI and RF24L01, RF24 libraries for wireless module, software serial, liquid crystal I2C, wire libraries. Because I also make where I display the result on my LCD. Define pin, we connect it to Arduino board and declare the function. We have to do this struct data to make things easier. When you start receive data from transmitter, you will get data from struct data. In the setup function, we start the serial begin for serial monitor, LCD initiate or start LCD, data serial begin to call or start the start of data and start the radio. We set the address as our reading pipe. We start listening because we only want to receive data. Then, in the loop, we're gonna put the title to our serial monitor. That will appear when we open our serial monitor. We check if there is data serial or from serial communication Arduino available. We get the value of GPS and heading error. Also, we calculate the distance. And if there is radio data available, so we read into our data structure. We print out our result and open serial monitor. Yeah, here is the result that we will get after upper this curve.
The data sent by the transmitter and received by the receiver will be linked with a node thread via the MQTT protocol and present in a real-time node thread dashboard. Before we start creating flow in Node-RED, we must first install Node.js, Node-RED, and Mosquito Broker as the MQTT broker. If everything is installed, let's get started. Open the command prompt and run Node-RED with typing Node-RED. The Node-RED is running. The Node-RED is connected to MQTT broker, and this is the server that the Node-RED runs on. And then open Node-RED in web browser. And input the username and password. This is the workplace Node-RED to create the flows, and the left side is flow nodes, and on the right side there is a menu. Scan, export, and import flows with JSON format, and on the manage part you can install flows. For example, you want to install dashboard Node-RED. You just typing dashboard and this dashboard can install. And this is the first monitoring buoy. There are three-part flows: temperature, humidity, and pressure data into one. Then compass data and GPS tracker to node position buoy. Okay, let me show you the settings of each node. And here is the dashboard node-RED to monitor the buoy. Data from the mosquito broker can already be received by the node-RED and displayed in the form of a dashboard node-RED.
Syergie Indo Prima telah memberikan kesempatan kepada kami untuk melaksanakan praktik industri tahun 2020. Hope you enjoy this video.
Thanks for watching.
Bye-bye.
Jangan mencari yang deketin.
Ya nggak kelihatan. Susah nih.